Okay, today we're going to talk about solutions of two linear simultaneous equations using inverse metrics. So, when you talk about simultaneous equations, we are talking about the situation where you have to solve two equations at the same time, find two variables, either x or y, and then we have a lot of methods in solving simultaneous equation. One, we have the um, elimination method. Elimination method, and two, we have the substitution method, and then three, we have the graphical method, and then four, we have the inverse matrix method. Inverse matrix method. So today we are going to talk about the inverse matrix method. Okay, all right, so these are some of the methods that you can use in solving simultaneous equations. So let's solve one example here under simultaneous equations, and then simultaneous equations come in the form of equations such as x minus 2y is equal to 3, sorry for that, and then write 2x plus 4y is equal to minus 6. So this is a simultaneous equation which you have to solve, and then find the value of x, and then find the value of your y. Then we can also have equation like 4x plus 5y, which is equal to 3, and then 2x plus 3y, which is equal to minus 1. So here you have to find your x, value for x, and then value for y, such that when you substitute the values of x and y into these equations, you are going to get 3. And then if you substitute the value of x and y into the next equation, you are going to get minus 1. So you normally label them as equation 1, equation 2, and then this one to, let's say, equation star, and then this one to equation star. Okay, so that is the concept of simultaneous equation. You have to solve for the value of x and then y simultaneously at the same time. Okay, so under our solutions of two linear simultaneous equations using inverse variation, we're going to use this one and solve for our x and then y. So let's take an example. So with our example, we say that solve the simultaneous equations 4x plus 5y is equal to 3 and 2x plus 3y is equal to minus 1 using inverse matrix. So you are going to use the inverse matrix approach in solving for our x and y in this simultaneous equation. So our solution, so we have two equations which we have to write them down. We have 4x plus 5y, which is equal to 3. Then we also have 2x plus 3y, which is equal to -1. So we first name our first equation as equation 1, and then our next equation as equation 2. Okay. So using inverse matrix, using inverse matrix, we can say that 4, 5, 2 and 3, and then we have our x and then our y, and then which will be equal to our 3 and -1 respectively. So in this case, we let A be equal to our first matrix, which is 4, 5, 2 and 3, and then we let P be equal to our x and then our y, and then H is equal to 3 and then -1. All right. So if we have this, then we say that AP is equal to H. So if we want our P, okay, so if you want our P, then you divide through by A, and then you have P is equal to H over A. But you realize that you cannot divide two metrics. So then, by our law of indices, this implies that P is equal to the inverse of A times H. Okay, so now we have to find the determinant of A, and then we have to find the adjoints of A. So to find the determinant of A, we have the determinant of A is equal to 4 times 3, which is 4 times 3, minus 5 times 2, which is equal to 4 times 3 is 12 minus 10, which is equal to 2. So then our adjoints, we have to find our adjoints, right? So our adjoints is equal to, our adjoint of A is equal to you have to interchange the first and then the last, the first number on the first row in the first column, and then the last number on the second row and then the second column. So you have to interchange them. So you now have 3 and then 4. Then with our 3 and 4, then we negate the 2 and then the 5. We have -5, then we have -2. So those ones becomes our adjoint. This is our adjoint. So then our P, let's continue from our P is equal to the inverse of A times what? Our H. Okay, so now our P is equal to the inverse of h is the determinant. Have the determinant 1 over the determinant of a times the adjoint of a. Okay, that's our a inverse. That's our a inverse. 1 over the determinant times the adjoint of a, right? And then our h. Okay, so let's continue from here. So now our p is equal to 1 over 2 times our adjoint, which is 3 minus 5 minus 2 and 4 times our h, and our h is 3 and then minus 1. So then our p will be equal to half. Have to multiply this, so 3 times 3 will give you 9, and then minus 5 times minus 1 will give you 5, so plus 5. Then minus 2 times 3 will give you minus 6, and then 4 times minus 1 will give you minus 4. So it is equal to 1 over 2 times 14 minus 10. Okay, so this one is going to give us 14 over 2 minus 10 over 2, which will give us 7 minus 5. Okay, so this is our h, this is our p, this is our p, but our p was x and y, so then our p is now 7 and then minus 5. And then minus 5. So then our p, which is equal to x, y, is equal to 7 and minus 5. Okay, so now our x is equal to 5, our x is equal to 7, and then our y is equal to minus 5. So you can substitute these values in here, and then you see that you get 3. So if you substitute 7 into 4, 7 times 4 which is 28, and then so 28 plus, so you just substitute this one in. This is what the way that you have to do. You substitute this one in and verify whether it's right. So from this question, go through this process. First, represent your equations in a matrix form. Then you find the adjoint of your a. You find the inverse by finding the adjoint, the determinant, and then you find your x and then your y. So then you solve through this process. So that is how we go about solving simultaneous equations using the inverse matrix form. Okay, so thank you.